Hello everyone, this is Easy Math. In this video, we are going to see Class 6 Mathematics Term 2, Chapter 1 Numbers, in which we are going to solve exercise 1.2. In the previous exercise 1.1, we have seen about the prime factorizations and the divisibility rules. Now in this, we are going to see about HCF and LCM. So let us take exercise 1. The question number first. What is HCF? It means highest common factor. The full form of HCF is highest common factor of 45 and 75 is the first question. So this is again the same. The basic concept here is prime factorization. If you are familiar with the prime factorization, this HCF and LCM will be very, very easy. So let us see now what is HCF. HCF is highest. So let us see the full form. HCF is highest, H for highest, C for common, F for factor. Highest common factor, and LCM is least common multiple. So now we are going to find the HCF and LCM of the given numbers, and the method is prime factorization. So what are prime numbers? Prime numbers are divisible only by 1 and itself. They have only 2 factors. So for example, can you list out the prime factors? Yes, prime numbers 2, 3, 5, 7, 11, etc. So I have been telling the same thing, children. Once again, I remind you all, please make yourself thorough with the prime numbers between 1 and 100 so that these HCF and LCM all they become very easy. Now let us go on to the first question. Exercise 1. Question number 1. 45 HCF of 45 and 75. See, find the prime factors of 45. Find the prime factors of 75. Now let us recall the rule of prime factorization. If a number ends with 0 or 5, we divide by 5. So till 45 comes 5 tables. 5 nines are 45. So how to write it? 5 nines are 45. So this 9 is the quotient. Here also 45, here also 45. So there is no remainder. So it is 5 nines. So this is the quotient we write here. Okay, 5 nines are 45. Now what is 9? 9 is a odd number. When it's an odd number, what is the rule? Divide by 3. So till 3 comes 3 tables, 3 3s are 9. And what is 3? It's an odd number and also prime number. It is divisible only by itself. 3 1s are 3. Now take up 75. Same thing, ends with 5, divide by 5. Till 7 comes 5 tables. We have 5 1s are 5 and 5 2s are 10. Which is less than 5? Well, less than 7. 5 is less than 7. So this one is the quotient for us. But here we have 5 and here we have 7. So there is a reminder. These two numbers are not the same. We have reminder. What is the reminder? After 5, count till 7. After 5, 6 and 7. What is the reminder? 2 is the reminder. Carry over with 5. Now in 25, 5 tables, 5 5s are 25. Got it? Now 15 is again ends with 5. Divide by 5. This is such a small number. We know 5 tables thoroughly. So 5 3s are 15. Okay. Now 3 is prime and also odd. It is divisible by itself. 3 1s are 3. Okay. So prime factorization is over. This one what we have learned already. Now what is the next step? Write the factors of 45. What are the factors of 45? 5 into 3 into 3 into 1. 5 into 3 into 3 into 1. How to check this answer? When you multiply all these factors, you should get 45. 5 3s are 15. 15 3s are 45. 45 1s are 45. Okay, right. Now take 75. 5 into 5 into 3 into 1. 5 into 5 into 3 into 1. Now, to find HCF, let us find common factors. What do you mean by common? C for common, F for factors. Common factors. The factor should be in both 45 and 75. Now tell me which are there. There is 5 in 45, there is 5 in 75. So this 5 is common. Next, 3 is there in 45, 3 is there in 75. 1 is there in 45, 1 is there in 75. Here we have 3, we don't have another 3. In this we have 5, but there is no 5 in 45. So be careful, children. Don't choose one factor. These two 5s, we cannot choose one 5. because both are factors of 75. Common means it should be in both. It should be common in 40. It should be common for both 45 and 75. The factor must be present in both the given numbers. That is the meaning of common. Okay. So 5 and 5, 3 and 3, 1 and 1. For these two 5s, write 1 5. For these two 3s, write 1 3, and for these two 1s, write 1. Now, these are the common factors. Now, what is HCF? You multiply all the common factors. That is the HCF. What is HCF? Multiply the common factors. Which are the common factors now? 5 into 3 into 1. Multiply them. 5 3s are 15, 15, 5 3s are 15, 15 1s are 15. So 15 is the HCF of 45 and 75. So just do the prime factorization, pick up the common factors, multiply all the common factors, we get the highest common factor. Okay, we'll move on to second question. What is second question here in the book? It says the HCF of two successive even numbers. What are successive even numbers? Successive means two continuous even numbers. For example, if 2 and 4 are successive even numbers, 4 and 6 are successive even numbers, 6 and 8 are successive even numbers. So what is the common factor among them? 2. The highest common factor is both the even numbers. They come in two tables. So the HCF of two successive means two continuous even numbers is 2 is the answer. Okay, next. The LCM of 3 and 9 is 9. Then the HCF. See children here, when among the two numbers, when one is a multiple of the other, 9 is a multiple of 3. What does it mean? 3 comes in 9 tables. So when 9 is a multiple of 3, this 3 becomes the HCF and the greater number becomes the LCM. So 9 is the LCM and 3 is the HCF. Next, the LCM of 26, 39 and 52. This we cannot tell the answer directly. We have to do the prime factorization as we did for HCF. So here LCM means least common multiple of 26, 39 and 52. Let us do this sum. Okay, so LCM of 26, 39, 42. Here, the difference between LCM and HCF. In HCF, we divided the numbers separately. We did for 45 and 75 in the first question. We divided 45 separately and we found the prime factors of 75 separately. Even the same method can be used for LCM also, but this is more easier than finding the prime factor separately. So in LCM, we write all the three numbers together in L division. We don't divide separately. All the three numbers together we write in L division and we divide by the common factor. What does it mean? By what number you can divide all these 26, 39, 42. You should check which is the common divisor of 26, 39 and 42. That means we have to check, we have to find a number in which table all the three numbers come. Again, children, I am reminding you all, you must be thorough with the tables. Up to 10, you should be very thorough. But if you are thorough with 16, thorough up to 16, all these sums becomes very, very easy. So as soon as you see the numbers, we can just find all the three numbers come in 13 tables. All the three numbers come in 13 tables. So all this HCF, LCM, factors, multiples, for all these, the only thing you should know is the tables. If you are thorough with the tables, this chapter is nothing. Just like that, you can do all the sums. Okay. So for 26, 13 2s are 36. If you know 13 tables, 13 3s are 39. 13 4s are 42. Okay, so 13 4s. So 4 is the quotient. 4 3s are 12. I'm sorry, not 13 4s are. It is, sorry children, the given number is 52. Then only it comes, not 42. The question, I'm so sorry, I've copied the question wrongly. The question is 52. So 13 4s are 52. So all the three numbers come in 13 tables. We have done it. It is not that all the numbers are not the same. It's not a single number. It is 26 is the first number, 39 second number, 52 third number. And again the second step, it is not 234. It is 2, 3, 4. All three different numbers. Now, you check whether all the three numbers come in the same table. 2, 3 and 4. 2 and 4 are even numbers, but 3 is not an even number. We cannot divide it by 2. So all the three numbers, they don't have a common factor. What do? You check whether any two numbers have the common factor. Yes, this 2 and 4 both come in two tables. So you put a tick for them, or you can circle them. You can just identify in whichever way you want. That means we are going to divide only 2 and 4. Both come in which table? Two tables. So till 2 comes, two tables, 2 ones are 2. See how to write it? No confusion. 2 ones are 2. This 1 is the quotient for us. Okay. Now, are we dividing this 3 by 2? 3 doesn't come in two tables. 3 is an odd number. We cannot divide by 2. So, we are not dividing this 3. Therefore, write that 3 as it is down. Got it? Whichever number you are not dividing, write the same number down. This is the only concept you should remember in LCM. Next, till 4 comes two tables. 2 2s are 4. What is the quotient? This 2, the middle number, is the quotient for us. So write that 2. Here also 4, here also 4, no reminder. Now 1, 3, 2. No common factor. You take any two numbers, 3 and 2, no common factor. 1 and 2, no common factor. Or 1 and 3, no common factor. Therefore, these three numbers, they don't have any number in common. So, a factorization is over. Now, what is LCM? Multiply everything from here to here, from the starting divisor till the end, last divisor. You multiply all the numbers. What is it? 13 into 2 into 1 into 3 into 2. Any doubt? 13 into 2 into 1 into 3 into 2. Now multiply them. 13 2s are 26. This 26 into 1. 26 ones are, what mistake you all make? 13 2s are 26. Then you say 2 1s are 2. Then you write 1 3s are 3. Then 3 2s are 6. Finally you end up with 6. That is not the way you multiply. Multiply the first two numbers 26. That answer into third number. So we multiply these two. 26 into 1 is 26. That 26 into 3. That 26 into 3 is 3 6 are 18. Carry 1. 2 3s are 6. 6 plus 1 78. We have finished with 3. Now that 78 into the last number 2. So 78 into 2 multiply, 2 8s are 16, write 6 carry 1, 2 7s are 14, 14 plus 1 15. So answer is 156. When you multiply 78 into 2, we get 156. So our LCM is 156. That is the answer for question number, which one? The fourth one, LCM of 26, 39 and 52 is 156. Okay. Next, the least number that should be added to 57 so that the sum is exactly divisible by 2, 3, 4 and 5. So what is the number you should add with this 57? Can you see this 57? What number you must add with 57? So that that answer is divisible by 2, 3, 4 and 5. What is the divisibility by 2? Shall we recall? Yes, all the even numbers are divisible by 2. Is 57 an even number? No, it is the ending with 7 is the odd number. To make it an even number, we can add 1. 58 is divisible by 2. But leave out 3 and 4. Look at this 5 children so that we can quickly guess the answer. If it has to be divisible by 5 means it should end with 0 or 5. The last number has to be 0 or 5. Then only it is divisible by 5. Now we have to add the number. So we cannot make it 5. If you want to make the 7 as 5, then we have to subtract. Now, but what should be added? So what number we can add with 7 so that this digit becomes 0? Can you guess? 57 plus what gives a number that is ending with 0? Yes, it is plus 3. If you add plus 3 with 57, we get 60. It ends with 0 so that it is divisible by 5, isn't it? 60 ending with 0 is divisible by 5. And ending with 0 is an even number. It is divisible by 2. And 60, it comes in 3 tables because 2 3s are 6 and 0 20 times. 3 2s are 6 and 0. It comes in 4 tables also. 54 into 15 is 60. So 60 is divisible by 2, 3, 4 and 5. So what is the number we are adding with 57? 3. 3 should be added with 57 so that 60 is divisible by all the 4 numbers. Okay. Now what is next? True or false? The numbers 57 and 69 are co-primes. What do you mean by co-primes? If their HCF, you are finding HCF, no children? If the HCF is 1, then they are called co-primes. That means they don't have any common factor. But here 57, if you add 5 plus 7, it's 12. It comes in 3 tables. 69 also comes in 3 tables. 6 plus, what is 9 plus 6 is 15. That comes in 3 tables. So both 57 and 69, they have a common factor 3. If the common factor is 1, if they don't have any other common factor, if 1 is the only common factor, then only they are called co-primes. But other than 1, 57, 69, both come in 3 tables. So they are not co-primes. So therefore the statement is false. Then the HCF of 17 and 18 is 1. Look at it. What are 17 and 18? They are consecutive numbers, continuous numbers or successive numbers. One comes after the other. So always the HCF of 2 continuous numbers is 1. This is true because they don't have any common factor. Can you guess, children? 17 and 18 both come in the same table. Do they come in any of the same table? 2 tables, 3 tables. This is there in 2 tables, 3 tables, 6 tables. But 17 is a prime number. It doesn't come in any of the tables. So they don't have any common factor. Their common factor is only 1. Both come in 1 table only. Next, the LCM of 2 successive numbers is the product of the numbers. Yes, just what do you mean by successive? Just like them, 17 and 18 are successive. 2 continuous numbers. So let us take some small example. 5 and 6 we'll take. They are successive numbers, continuous numbers, just like 17 and 18. And what is the LCM? Means we should divide by the common factor. 5 and 6, can you guess? Do they have a common factor? No, both the numbers, they don't come in any of the same table. Now, how to find the LCM? We just multiply them to find the LCM. That is 30. What is the meaning of multiplying? Product. So, 2 continuous numbers, they don't have a common factor. So, to find LCM, we multiply them. That means the product. So, this is true. The product of the 2 numbers, 2 successive numbers is their LCM. Next, the LCM of 2 co-primes is the sum of the numbers. What are co-primes? Their common factor is 1. For example, we can take 5 and 6 itself, or you can take some other number. 7 and 9, let us take for example. 7 and 9, what do you mean by co-primes? Both, they don't come in any of the same table. That means their common factor is 1. Then, how to find the LCM? Just like the previous one, it is just the same meaning of the previous question, but only the way the question is given is different. Co-primes means their common factor is 1. The HCF is 1. How to find the LCM? If they don't have a common factor, we have to multiply them. But what is given here? Sum. It is wrong. Only when you multiply, we get the LCM. When you're adding, we won't get the LCM. So this is 7 and 9. The LCM is 7 into 9. Only the product is correct. But the sum is wrong. The statement is false. The HCF of 2 numbers is always a factor of their LCM. For example, let us find HCF and LCM of 2 numbers and check this. HCF of 2 numbers is always a factor of the LCM. Yes, children, this is true because LCM is always greater and HCF is a smaller number among the given 2 numbers. So the HCF will be definitely always a factor of the LCM. For example, let us take 3 and 6. If we take 3 and 6, 3 is the HCF, 6 is the LCM. And this HCF is a factor of 6. That means 3, 6 comes in 3 tables. So 3 is a factor of 6. Therefore, this statement is true. Okay. So let us stop this video with this and rest of the sums we'll see in the next video. Thank you all for watching. Thank you.